I would rather say कि husband
Hi, guys. Good evening, everyone. So, sometimes you will be having this, so like when you will try to open the phone, some videos and shorts will open. So, because of that, some or other things gets open sometimes. So, yeah, good afternoon, everyone. So, I was checking that. So, how many of you guys actually face this problem? Like I have just now faced that. So suddenly, like the icon clicked on the shorts and YouTube shorts, and it just some random video started. Okay, no problem, guys. So let's just start with the topic. Let's just talk about that. Yes. So what we have to do today, guys, we'll be discussing about salt hydrolysis, which is a really important topic of ionic equilibrium. Okay, and before starting about this topic, so all those new learners who are there on our platform, what we'll be doing will be just quickly yes, introducing each other. So I'll be introducing myself, and you guys, those who are there on the platform, you can also introduce yourself in the chat. So guys, I'm Manisha Rani, your chemistry educator at Unacademy, and I have experience of online and offline teaching at reputed institutes for more than 5 years. I have completed my master's from NIT Warangal and bachelor's from Delhi University. I have cracked many reputed exams like IIT JAM, CSIR NET, and GATE. I have given best ranks through my students, and yes, I'm a plus verified tutor. So, guys, we'll be learning today about salt hydrolysis, and without wasting time, let's just learn about it. So, all of you guys know that how you get salt, right? When an acid reacts with a base, all of you must be knowing what is neutralization reaction, yes or no? What is neutralization reaction? Everyone knows? Yes, neutralization reaction is when an acid reacts with base. It gives salt and water. Very good. Now, what you have to understand here that what is salt hydrolysis and how we can understand about it. So, good afternoon, Abhishek. How are you? So, what we can understand regarding hydrolysis of salt. So, hydrolysis of salt. First of all, what is the meaning of hydrolysis? Hydrolysis means you can relate hydro means water, correct? Hydro means water and lysis means breaking. So, breaking of something in water, right? Now, what is that something? Salt. So, you'll be breaking salt into its ions. Correct. I'm also good, Abhishek. So, talking about it, everyone, yes, let's just discuss regarding hydrolysis of salt. That hydro means water, lysis means breaking. So, we are talking about breaking of salt in the presence of water. So, how we can relate about hydrolysis of salts? It's very simple. Ions produced by the dissociation of salt, ions produced by the dissociation of salt salt reacts with water to produce either hydroxide or hydronium ion. Produce either hydroxide and hydronium ions. So basically, yes, what we can relate that when you will you will add salt to water, what is going to happen? It is going, if it gives acid plus base back. Now in this acid and base, obviously the ions of one particular substance, if it is more, the pH is going to get affected, and that's what we can relate. So it's very simple. Hydrolysis of salt is nothing but it's just a opposite reaction of neutralization reaction. When you add salt plus water and you get acid and base back, You can relate that it is nothing but hydrolysis of salt, right? But what do you think, that every salt can do that? Yes, if you will add like sodium hydroxide plus HCl, you will get NaCl plus water. But if you will add NaCl in water, will you get again sodium hydroxide and HCl? What say? So let's just understand about it, that which and all salt will undergo hydrolysis and which and all salt will not undergo any hydrolysis. Okay, so let's just understand about it, that which and all, yes, salts can undergo hydrolysis. Let's just understand that. So how you will check that? You have to take a salt, whatever you have, that you put in water. The moment you will put salt in water, you will get an aqueous solution. Yes or no? Because generally salts, they get dissolved in water. What you will get? You will get aqueous solution of salt. Now this aqueous solution, you will check what is the nature of it. If the nature is neutral, if the solution's nature is neutral, or whether it's acidic or it's basic. So this we have to check, because accordingly only we can find it out, yes, that whether it will undergo hydrolysis or not. So what you did, say you took any salt, you dissolved it in water, and once you dissolved it, you will get an aqueous solution. Now once that aqueous solution is obtained, yes, you will check what is the nature of it, whether it's neutral, acidic or basic. If it's neutral, guys, like sodium chloride, if it is neutral, then there will be no hydrolysis. There will be no hydrolysis, correct? But if I talk about if it is acidic or basic, yes, hydrolysis will be occurring, right? So there will be hydrolysis will occur, and here also hydrolysis will occur, correct? But if it is an acidic solution, what type of hydrolysis occur, guys? If the aqueous solution is acidic, a cationic hydrolysis occurs. A cationic hydrolysis occurs. While if it is a basic solution, what happens? Anionic hydrolysis occurs. Now how we can relate, we'll be understanding about it. Okay, so basically we understood salt hydrolysis is just a opposite of neutralization reaction. When we add in salt water, what we get? Yes, we get acid plus base back. So now depending upon when we are getting acid and base, which one is more, like acid content is more, base content is more, right? Or if both are having a same concentration, we can have the nature of solution. Very good. If it is neutral, if the solution is neutral, means H plus and OH minus ion concentration is same, so you will say there will be no hydrolysis, means this type of salt will not undergo hydrolysis. While if it's an acidic salt, it will undergo hydrolysis, and if it's a basic, it will also undergo hydrolysis. But specifically if we talk about if it's an acidic salt, it will undergo cationic hydrolysis, and if it's a basic salt, it will undergo anionic hydrolysis. Now what is the meaning of it? Let's just understand. Okay, so basically let's just take an example. Okay, but before that I want to tell a simple thing, that how you can check whether a salt is going to give hydrolysis or not. You will check, suppose if both are strong, so if you take strong acid and strong base, what is going to happen? You will get neutral salt, there will be no hydrolysis. Means when you add strong acid plus strong base, the salt that you are going to get is going to be neutral and it won't give you hydrolysis. Okay, so the salt here doesn't undergo any hydrolysis. Very good, no hydrolysis. Okay, so when this is the case, when two, like one strong acid and strong base reacts to give a salt, it won't undergo any hydrolysis. But suppose if you have a strong acid plus weak base, or say strong weak acid plus strong base, or suppose if you have weak acid or weak base, if all these things they are reacting and giving a salt, in all these cases what will happen? Yes, hydrolysis will occur. So hydrolysis will occur when at least one thing has to be weak. It's very simple. Yes, at least either acid or base which you are adding to make a salt, one has to be weak. If one is also weak, the hydrolysis is going to occur. Okay guys, so you can relate. If you have one, it will occur. One, if both, obviously it is going to occur. So remember that. But if both are strong, there will be no hydrolysis. Very good. Now talking about the next thing, what we can relate here. Yes, let's just understand about one important thing, that if we have understood that these and all, they are going to undergo hydrolysis. So for that solution, we can understand with one of the example and then we'll relate. Suppose you're taking a strong acid and weak base. Let's just understand. Strong acid plus weak base you are taking. So strong acid plus weak base you are taking to form a salt. Let's just say you are taking HCl plus NH4OH. Okay, what you did? You took HCl plus NH4OH. HCl is a strong acid, hydrochloric acid, while ammonium hydroxide is a weak base. When you will add both of them, you will get ammonium chloride as a salt, plus you will get water. Because how you will get it? See, HCl will dissociate in which ions? HCl will dissociate as H plus and Cl minus ion. Ammonium hydroxide will dissociate as ammonium and hydroxide ion. So oppositely charged ions, they are just going to combine and form a salt. Correct. Like Cl minus will combine with NH4 positive, will give you NH4Cl. H plus will combine with OH minus and it will give you water. So like that you will get product. Okay. Now what you can relate over here? I got this ammonium chloride. So whether it will undergo hydrolysis or not, let's just see that. So you have, say, ammonium chloride. When you will take its solution, you know that it is going to give ammonium plus chloride ion. Correct. Now, if I relate which ion in ammonium chloride you have got from weak substance, ammonium or chloride? Tell me. Abhishek. Yes. Yes, Pradyuman, tell me, everyone. So ammonium and chloride. Out of that, which is coming from weak? Which ion is coming from weak? Ammonium, right? It comes from weak base. Yes or no? So the ion which comes from weak base is going to undergo the hydrolysis, or it is going to be responsible for the hydrolysis. So because if you will say that when I take strong acid plus weak base, what will be the solution? Solution will be acidic solution now. Because if you are taking a strong acid and you are adding a weak base, who is dominating? Strong acid is dominating, no? Yes, strong acid, weak base. So which character will be there in the solution? Acidic, right? Yes or no? The salt which you are going to get is going to be acidic salt. I hope everyone is able to relate, because one is strong, another is weak. So the one which is strong, your salt is going to get the characteristic of that only, no? Yes or no? So you will get acidic salt here. Very good. And if it's an acidic salt, ammonium chloride is the acidic salt. So acidic salt, it gives ammonium plus chloride ion. Which ion comes from weak is ammonium ion. So ammonium is a cation. So that's why we can relate that if it's an acidic salt, yes, it's an acidic solution, because acidic salt, if you add in water, you will get acidic solution. So if it's an acidic solution, it gives cationic hydrolysis. Cationic hydrolysis, because what will happen, the ammonium ion, that is going to react with water and it is going to give, you know what, ammonium is going to react with water. So ammonium is going to behave as an acid, it's going to lose H plus ion, and water is going to behave as base. Now what it is going to do, it is going to gain. So basically ammonium ion will undergo hydrolysis, it is making water to be, yes, breaking, and then reaction is happening. So ammonium plus water gives ammonia plus hydronium ion. It's an acidic solution, so pH here is going to be less than 7. Very good. But specifically, if they give you any solution and you have to calculate the pH, you can calculate by a formula which is nothing but pH is equal to half pKw minus half pKb, because B, you will take that one which is weak. So here weak base is there, so I'm taking pKb minus half log C. So this way you can find it out the pH of this solution, and also you can find out few of the thing, like you can find it out what is hydrolysis constant, right? You can find it out hydrolysis constant, and also you can find it out the degree of hydrolysis. Like we calculate equilibrium constant, no, same way you can calculate hydrolysis constant, concentration of products divided by concentration of reactant. That's how we do it. But we have a specific formula by which we can find it out. We can find it out Kw by Kb, because the one which is weak, that you're going to put down to the numerator. And how you can find it out, the degree of hydrolysis? It's very simple. H is degree of hydrolysis and KH is what? Hydrolysis constant. Hydrolysis constant. So H is equal to Kw divided by Kb, but you will take root, and that you will also, Kb you will also multiply with the concentration. So this way you can calculate degree of hydrolysis. So what we understood the case 1 over here. Case 1, when I take strong acid plus weak base, how the hydrolysis will occur? Hydrolysis will occur due to cation. So it is a cationic hydrolysis. The pH is going to be less than 7. How you can calculate the pH? There is a formula for it. Yes. How you can calculate pH? There is a formula for it. Also, how you can calculate hydrolysis constant? For that also there is a formula. And also for degree of hydrolysis, there is a formula. What is C over here? C is concentration. Kb is dissociation constant of base. Kw is dissociation constant of water. Yes. Dissociation constant of water. B is dissociation constant of base. Because weak base you have taken, so we will talk about that only. And C is concentration. Simple. Very good. Now let's just talk about this case 2. So if we have second case, what we can relate in that? So you are taking weak acid plus strong base. So weak acid plus strong base you are taking. For example, you are taking CH3COH, acetic acid, plus you have taken NaOH. So when you will add both of them, what salt you will get? You will get CH3CO, Na as a salt plus water. Very good. Now the salt that I have got it, which is sodium acetate, this, right, is going to give which and all ions? Acetate ion, CH3CO minus plus Na plus. Okay, very good. It means it constitutes this ion. Out of both the ions, which is coming from the weak one? Acetate ion. No, this is coming from weak acid, correct? So what you can relate? Because this is an anion, so what is going to happen? Remember, when you're taking weak acid plus strong base, it will make basic salt. Why? Because the one which is stronger one is going to dominate the reaction, correct? So you will get a basic salt. Now once you got the basic salt, it will undergo anionic hydrolysis. Why? Because here you are getting anion from the weak substance, right? So what we can relate? You will have what? Anionic hydrolysis is there in anionic hydrolysis is by basic salt. Very good. Now what we can relate? I have got acetate ion. This acetate ion can react with water, and what will happen? Because this is from a weak acid, so weak acid conjugate base, it's going to behave as the base obviously, so it will accept H plus ion, CH3COH, plus here you will get OH minus ion. So basically what you can relate here, this acetate ion when reacts with water, it will give you acetic acid plus hydroxide ion. pH, because it's a basic salt, so pH is going to be greater than 7, and if pH is going to be greater than 7, that we can relate. But how you can calculate the exact pH? The exact pH formula will be half pKw, the same like the previous one, but here you will be having plus half pKa, because weak is acid here, plus half log C. So this is the formula to calculate pH. You can calculate same way KH also. Yes, the hydrolysis constant. So because there it was weak base, so I took Kw by Kb. But here there is a weak acid, so I will take Kw by Ka, dissociation constant of acid. And alpha is there for normal one. Here we are talking about hydrolysis, degree of hydrolysis. So degree of hydrolysis, what I can relate? H is going to be equal to what? H is going to be equal to, yes, it is going to be root, because we take root Kw divided by Ka, but that you have to multiply to C. So that we can calculate easily. Very good. So this was the case 2, when you take a weak acid plus strong base. Let's just discuss the case 3, which is nothing but when you take weak acid plus weak base. Okay, like for example, you are taking acetic acid CH3COH plus NH4OH. You're taking weak acid plus weak base. So what is going to happen? Obviously, it is going to make a salt. How you can relate? You can check the ions. It is going to give NH4 positive and OH minus ion. So you will just combine the ions. So you will get ammonium acetate salt plus water. So you got this ammonium acetate salt. Now here, it can depend that what type of hydrolysis it will be. So here both cationic and anionic hydrolysis is going to take place. Why? Because both the ions, acetate and ammonium, both we get from weak acid and weak base. So both can undergo hydrolysis. Like if I'll say CH3CO minus, when it will react with water, what is going to happen? It is going to take CH3COH plus OH minus ion, it is going to form. And ammonium, when you will react with water, what is going to happen? Yes, you are going to get ammonia plus hydronium ion. So here both type of hydrolysis will be there. So cationic also can occur, anionic also can occur, but depending upon, because you are taking both weak acid and weak base. Now out of that, which is having more concentration, that is going to define which hydrolysis is going to occur. So if dissociation constant of A is greater than dissociation constant of B, yes, then acidic solution, because both are weak, but acid is slightly better than, like slightly stronger than base. If say Ka is less than Kb, then basic solution, correct? You can relate that. And if K is equal to Kb, then it is a neutral solution. In that case, no hydrolysis. Okay, so because when we consider strong acid and strong base, they completely get dissociated into ions. So for strong acid and strong base, there will be no hydrolysis for sure. But when there is weak acid and weak base, so you have to check which one is more weaker. Like if acid is a stronger one than the base, because say what we can do is we can do comparison, right? Say when we have weak acid and weak base, like we suppose if we can relate that we have a dog, right? Like we have two dogs, but depending upon who is having little more strength, both are weak, right? So we have two elephants and we have two dogs. Dogs in comparison to strength, they both are weak, but we can compare. But when we say elephants that they are generally huge, so they are very strong physically, right? So for them, we don't have to compare specifically, but when we talk about weaker one, when we are taking two weak, in that also we can relate which one is little strong, more strong, and accordingly we can find it out, correct? So when both are weak, how you can find it out? pH, guys, you can find out the pH by a formula, half pKw minus half pKa minus half pKb. So here concentration we are not taking because both are weak. So both I have to include in the formula, half pKb. So pH you calculate, half pKw is there in every formula. Now here half pKa minus half pKb. You can calculate KH. KH is Kw because both are coming from weak. So I will take both K and Kb. And what will be the H? H will be just take square root of Kw divided by Ka into Kb. So this way you can find it out, the KH as well as H for the solution. I hope everyone is able to relate with it. Very good. Now if I talk about the next thing, guys. Yes, how you can remember these formulas. See, I'll tell you. In the first case, strong acid and weak base was there. So whatever will be weak, that will be there in the formula. Now tell me, guys. First you get, whenever you say always AB, like here I'll make you one thing in the easiest, that you say always AB. No one says ABCD as like BA. Always we say AB, A comes first, then B. And always when we say positive, negative, right? When we remember these signs, we say positive, negative, not negative, positive. So remember, when acid will be weak, remember, when acid will be weak, in the formula, whole will be having a positive sign. When base will be weak, yes, in the whole formula it will be negative sign. See, you can remember. When I was having base weak, in the whole formula, there was a negative sign of pH, correct? In the pH whole formula, it was negative. And whatever is weak, that I will include. pKw is common, log C is common. I'm taking pKb because this is coming from weaker one. If acid is weak, in the whole formula of pH, there will be a positive sign, correct? And I will take pKa because acid is weak. Simple. When both are weak, so in the formula, before acid, A comes for, like before acid and base, when you will relate that. So here you have to understand one very important thing, that for acid, because we say positive, and for base it is going to be negative. So this will be the correct sign for the formula. pH is equal to half pKw plus half pK minus half pKb. Because you can remember positive, negative, AB. For weak acid, it will be a positive sign. For weak base, it will be a negative sign. Like that you can relate, and both are there, so both sign will be present. I hope everyone is able to relate. Yes, it's very simple. Talking about the case 4, when you take strong acid plus strong base, the most favorite, yes, there will be neutral salt, you will be getting always, and there will be no hydrolysis because pH will be equal to 7, it will be neutral, and there will be no hydrolysis. No need to calculate pH, KH, H, anything. Yes guys, I hope everyone is able to relate with it. It's so simple. So what we discussed about hydrolysis of salt today, guys, very important topic. I told that hydrolysis of salt reaction is just opposite to neutralization reaction. What you do when you add salt plus water, if you get acid plus base back, you will say hydrolysis of salt will occur. If you want get, you will say no hydrolysis of salt is going to occur. Then you will check the solution. Once you got the salt, yes, you will dissolve that in water. You will check the aqueous solution which you have got, whether it's neutral, acidic or basic. If it's neutral, no acid hydrolysis. If it's acidic and basic, hydrolysis will occur. If it's acidic solution, there will be a cationic hydrolysis. If it's basic, it will be anionic hydrolysis. Then we discussed about all the cases in which hydrolysis is possible, like strong acid plus weak base, weak acid plus strong base, weak acid plus weak base. For all of them, we learned how you can calculate the pH, how you can calculate the hydrolysis constant, and how you can calculate the degree of hydrolysis. So all these things we have discussed, all the formulas. I hope everyone have understood. Anyone is having any doubt, you can ask, guys. Tell me, everyone. Anyone having any doubt? Yes? Very good, guys. So make sure you are revising this topic. And if you like this session, guys, you can also go through. Yes, you can also come to our special classes, which are absolutely free on our Unacademy platform. Yes, and you can learn absolutely free in our special classes. And there, yes, you will be getting to know about many of the things. So we'll be discussing about the topics. You can also tell some of the topics in the comment box if you want to learn any of the specific topic from me. Okay. So, okay guys, make sure you are revising all these topics, and we'll be meeting in the next session then. Thank you everyone. Bye-bye. Make sure you're pressing the bell icon so that you will be getting all the notification regarding my classes. Thank you everyone. Bye-bye.